Okay, we're going to start off with solving equations. You probably know all this, but still go through the whole thing, take notes, write everything down, and do it the right way in order to get the best out of it. First, I want to talk about solving equations just in general. And you got to think of the equation as a scale. So what's on one side is equal to what's on the other side of the equation. So it's something that looks similar to this. Okay, here's a visual for you. 9 plus 8 is equal to 17. And remember, whatever you do to one side, in order to keep it the scale level, in order to keep it equal, you would have to do the same operation to the other side. Just like this. So if I add 3 to one side, I add 3 to the other side, now they're still equivalent, they're still equal, and the scale is still level. Okay, so here we get started, starting with a simple one. X plus 4 is equal to negative 12. So I'm solving for x. That's going to be the directions. So in order to get x by itself, I have to get rid of this 4. And to do that, I'm going to do its inverse operation. So because it's a positive 4, I'm going to subtract 4. But if I do it on the left side, I also need to do it on the right side. So then I have x is equal to negative 12 and negative 4 are both negative. So remember your rules for integers. Same sign, keep the sign, add the numbers, negative 16. Okay, this next one, still solve for x. But in this case, I have 4 times x plus 5 is equal to 3. And I'm kind of going to do this in reverse order. So I first have to get rid of the 5. Because it's a positive 5, I'm going to subtract 5. Again, from both sides. Those are going to cancel out. I'm left with 4x is equal to, these are different signs now. Subtract the numbers. 5 minus 3 is 2. Keep the sign of the larger number, so it's a negative 2. Now I have to get rid of the 4. Okay, and because the 4 is being multiplied to the x, I'm going to do its inverse operation, which is to divide. So I'm going to show that by a fraction. They're going to cancel out and become 1x equals 2 over 4 reduces by 2, so it's going to be negative 1/2. Remember to pause if you need to. You can go back and rewind it if you need to. I'm going to go on to the next problem. Same thing here. We're going to solve for y though. The variable is y this time. Again, these two sides are equal. Before I can start moving things, because this 3 is being multiplied to this parentheses, I'm going to have to distribute that. So the left side is going to stay the same for right now. The right side, I'm going to multiply it into the parentheses and distribute. So that's going to be 3y minus 9. Positive times negative stays a negative. 3 times 3 is 9. On each side, combine any like terms if you can. If you can't, now I'm going to get everything like terms on one side. So if I move this 3 over here with this one, in order to get rid of it on the left side, I'm going to have to use the inverse operation. It's a positive 3, so I'm going to subtract 3y, and I would have to subtract 3y over here. So I have negative 27, 6y minus 3y becomes positive 3y, and negative 9. Now I'm going to want to move this 27 over to the other side. In order to do that, it's a negative 27, so I'm going to add 27. and I get 3y is equal to -9, positive 27. They're different signs, so subtract the numbers. 27 minus 9 is 18. And then keep the sign of the larger number. And now to get the y by itself still, again it's being multiplied with 3, so I'm going to divide by 3, and I have y is equal to 6. 18 divided by 3 is 6. Remember, if you have any questions, write them down. Make sure you remember where they were, what it was applied to, what the question was about, and ask them first thing the next day. Okay, here's another one with parentheses. So that's the first thing I'm going to do, is distribute that 5 into that parentheses. It's only the 5 that's being multiplied to that parentheses. The 3x is going to be added to it. So 5 times x is 5x. 5 times 3 is 15. And then on the other side of the equation I have 2x minus 9 still. Before I start moving things to other sides of the equation, I'm going to combine my like terms on each side of the equation if I can. So on the left side it has two of the terms have x's. So I'm going to combine those. Remember, you can combine terms as long as they're alike. So 3x plus 5x is going to become 8x. So I have 8x plus 15 is equal to 2x minus 9. Okay, now I'm going to bring my x's together. In order to get rid of this 2x on the right side and bring it over to the left side, I'm going to have to use the inverse operation, which is subtracting 2x. I'm not going to put that line under it. Subtracting 2x, and I do that from both sides, and I have 8 minus 2 is 6. 6x plus 15 is equal to -9. Make sure that subtraction sign stays there. It doesn't go away. That's one mistake that I'll see, is people will just put 9 there, but the negative sign stays with it. Okay, now I have all my x's on the left side. Well, I also want to get all my constants then to the other side. So this 15 needs to be removed from the left side. So I'm going to have to subtract 15 from there. But if I do it there, I also need to do it over there to the right side. So I have 6x is equal to -9, -15. They're both negatives, same sign. Add the numbers, keep the sign to negative. So it's going to be -24. Now I have 6 times x. To get rid of that 6, my last step, I'm going to divide by 6. So that means x is equal to a negative divided by a positive stays a negative, and it's -4. Okay, so here the directions are: is the equation always true, sometimes true, or never true? In order to do this, you're going to solve it the same way. Okay, so you're going to combine your like terms that are on the same side. So this 11 and -7 are going to combine first, and that's going to be 4 because they're on the same side. One mistake that I see a lot with this is people will want to do this and add 7 to both of those, but the equation is right here. So if you do that, you're really adding 7 twice to the same side of the equation. So be careful with that. Make sure they're on the same side. 11 is positive, the 7 is negative. So you're really just doing positive 11, -7 combined to be 4. And I'm going to keep that 3x there as well. Combine your 6x with -3x, and that's going to be 3x. Okay. Now I'm going to get my x's on the same side. So I'm going to subtract 3x here. and subtract 3x here. So I have 4. These cancel out, but these cancel out as well, and I'm left with 4 is equal to 5. This is a special case when the x's cancel out completely. You're not left with any x's, you're just left with 4 equals 5. Well, because that is not a true statement, 4 does not equal 5, this equation will never be true. Okay, here's one that's similar. Combine your like terms that are on the same side of the equation if you have to. You can draw a line or a dotted line there on the equation part so you know that these two x's are on the same side, so you're just combining them. Positive 6, negative 2 become positive 4. I still have that 5 there. There's the equal sign. 4 and 1, they're both positive, so that's 5. When I subtract 4x here and subtract 4x here, again it cancels out on both sides, and I'm left with 5 is equal to 5. Well, in this case, you're left, all the x's cancel out, but you're left with a true statement. So the answer here is actually that this equation will always be true. And the sometimes true is what all the other equations have been like. When you're left with an answer, x is equal to 5, x is equal to 6, x is equal to 2, whatever, that's when it's sometimes true. If you do get a solution for it, that's the sometimes. Okay, at the end of the notes I give you some you try problems, which these you're going to try on your own, and come to class and we'll go over the answers, and if you have any questions we can fix those and discuss any problems with that. Okay, so this first one is solve for x. Do what you learned in the previous questions and solve for x. The second one is determine whether it's always true, sometimes true, or never true. Okay, also I like to give you a little joke at the end of some of the notes. So here's a joke for you to start you off. Alright, so what's an owl's favorite subject? Algebra. Get it?